Okay, so this video will show you how to reconcile the two concepts that we learned in the previous two videos. These concepts are, first off, the budget line, which looked like this and showed you what you can and cannot afford given the constraints you face. These are typically the prices of the goods and your income. This represents what you can have. P1 x1 plus P2 x2 equals M, where P1 is the price of good 1, x1 is the quantity of good 1 consumed, P2 is the price of good 2, x2 is the quantity of x2 consumed, and M is your total income. Notice that there is an equal to sign here, which means that this line is fixed because it is equal to something. You cannot move the line up or down graphically. By contrast, an indifference curve looks like this, and this tells you what you'd like to have or what you'd want to have. The most typical function for an indifference curve is a with x1 to the power alpha, x2 to the power beta. Notice how there is no equal to sign. This means that the curve can move. A consumer makes decisions based on what they want to have and what they can afford. As a rational consumer, you have a lot of bundles to choose from that you can afford, which are all the points in your budget set, but only some that align with what you want to have. In our case, there will only be one bundle that you can afford and what you want. Stating this a little bit more formally, there will only be one bundle that will help you maximize your utility from consumptions given the constraints you face. Now let's look at this graphically. Let's look at the budget line because it represents your constraints and will be a single line that does not move. Say x1 and x2. Let's assume you're buying apples and oranges. Let's say apples cost $1 and oranges on the y-axis cost $2. And let your income be $60. You'll start by labeling the axes as apples and oranges. The next steps are to find your intercepts. For more details on this, take a look at the first video in our series. Here, your x-intercept will be 60 and your y-intercept will be 30. Connect these 2 points and make sure that this line will not move. Next step is to draw ourselves an indifference map. Let's just say this are 3 curves. This really depends on you. You just really want to get a picture of what the scene looks like. So let this be the Cobb-Douglas function. Now let our utility function be 5x1 to the half and x2 to the half. So what you want to do is to just draw. Now let's take 4 points, and now we'll try to analyze whether or not the consumer will consume at each of these points. Now here, point A lies on the utility level 5. Point A lies on the utility level 5. This point is under the budget set. If our consumer buys this, he will have some leftover income. In our situation, savings is not a valid good. You can either spend on apples or oranges. If he consumes A, he will have a pile of income lying around unused. The rational consumer wants to maximize their utility and has the means to increase the consumption. He will not choose A. This should give you a hint that you'd want to go closer to the budget line, where he uses all of the resources at his disposal in order to be as happy as he can. Let's take a look at point B. While your level of utility is pretty high at 8, your budget line is telling you that you can't afford this bundle. This should again point to the fact that you want to ideally be consuming on your budget line. Now that we know that he's going to consume a bundle that lies on the budget line, let's move to point C. Point C lies on the budget line and gives you a utility of 6, which is great, or is it? Let's try moving towards the left while staying on the budget line. Now we're on point D, we're on the budget line, and we're on the highest indifference level that we can reach, which is 7. This seems like a great point to consume at, and is also mathematically the best point you could be at in terms of constraint maximization. D is the one we'll consume. Looking at it graphically, what you're doing is to try and push an indifference curve as high as it can go while still touching the budget line. As you can see, the farthest up that we can push it is when it's barely touching the budget line. If I take this indifference curve and push it up, I will keep pushing it up until it is tangential, and there's only one point where it is touching the budget line. Going back to math for econ, a cool property about tangents to curves is that the slopes of the line and the slope of the curve are equal. At this point, slope of indifference curve equals the slope of the budget line, which is also called. We know from the previous video that the slope of the budget line is the ratio of the prices of the two goods, which is P1 over P2. The slope of the indifference curve is mu of x1 over mu of x2. Now we just need to equate the two and solve. P1 is 1 and P2 is $2. This marginal utility of x1 is du over dx1, 5 multiplied by 1 over 2 root x1 multiplied by root x2, which upon simplifying gives you 5 over 2 root x2 over x1. Mu of x2 similarly is du over dx1, which I can get as 5 multiplied by root x1 multiplied by 1 over 2 root x2, which again simplifying is 5 over 2 root x1 over x2. Half equals 5 over 2 root x2 over x1, 5 over 2 root x1 over x2, and I can cancel these out, is now root x2 over root x1 multiplied by, take this on the top, divide by root x1, root x2, which is just x2 over x1. And now we know that this equals this, x1 equals 2x2, which we get by cross multiplying. This is number 1. How do we solve this now? Is by plugging this into our budget constraint. So our budget constraint we have is x1 is 2x2, and our budget constraint tells us 1x1 plus 2x2, which is 1 of apples, $2 of oranges, equals 60. But I know that x1 is 2x2. If I just make this substitution right here, I get 2x2 plus 2x2 is 60, which means 4x2 is 60, which means x2 is 60 over 4, which is 15. Now if x2 is 15, x1 is 2 multiplied by 15, which is 30. So my final consumption bundle is 30, 15. Oh, that's 105, 15. Now, we can also do the same thing by employing the method of the Lagrangians. You know, this is your utility function, and your budget function is x1 plus 2x2 is 60. We can solve this by using the Lagrangian, which you should have known from Math for Econ 2. And so the Lagrangian, the function is defined by what you are trying to optimize minus lambda of the constraint. So that means we have the Lagrangian is 5x1 half x2 half minus lambda x1 plus 2x2 minus 60, right? And now we need to take the first order conditions and set equal to 0. So we need dl by dx1, which by the first order condition is 5 over 2 root x2 over x1 minus lambda equals 0. dl over dx2 is 5 over 2 root x1 over x2 minus 2 lambda is 0. Now we want to isolate the lambdas and set them equal to each other. So this gives me 5 over 2 root x2 over x1 is lambda. And this gives me 5 over 2 root x1 over x2 is 2 lambda, which gives me 5 over 4 x1 over x2 is lambda. Now this is lambda and this is lambda, so I can equate the two, and I get 5 over 2 root x2 over x1 is 5 over 4 root x1 over x2. Simplifying this and canceling out and cross multiplying, I get finally x1 is 2x2. This looks familiar. This is indeed from the last step, and the third step is to substitute this into the third thing, which is dl over d lambda. Just going to erase this, and that is just x1 plus 2x2 minus 60 equals 0, which is x1 plus 2x2 equals 60, which is my budget line, right? So I take these two together, substitute for x1 in here, and that gives me 2x2 plus 2x2 equals 60, which then again gives me x2 equals 15, and x1 is 30. So I'm consuming at a bundle 30, 15. A major condition is that the utility function and the constraint need to be differentiable at all points to use either the MRS equals slope or the Lagrangian. If they're not, the best way to solve the maximization questions is to go back to the basics and try to push your utility curve out while still touching on the budget line. Thank you for watching, and come to the ULC either at U-Haul or the ARC for any other help that you need with your courses.